Okay,
which I think was
just a minute. Let me open it up. Um, yeah. On which page?
it's the one about gay loose Sachs law. It's a couple of pages down.
We are done with this. This one?
Yes, yes, this page.
All right, fine. So we need to do this. All right. Okay. So have you started it? No.
I
All
have
right.
not. No.
All right. So this is about PV is equal to nRT. That's the basic that we have to apply. PV is equal to nRT, where P is in ATM, V is in liters, N is the mole, and T should be taken in Kelvin, and R is a gas constant, and the value is 0.0821 ATM liter per mole per Kelvin, right? So now we are going to start this. All right. Should I start?
Yeah.
Okay, so we have if I have 4 moles, if I have 4 moles of a gas at a pressure of 5.6 atm and a volume of 12 liters, what is the temperature? So that means we need to find the temperature. We have the formula PV is equal to nRT. The very first thing you are going to do, which is going to make your work very easy, Sonia, is to modify the formula in terms of Gay-Lussac law. Are you getting my point?
Yes.
Yeah, so I would start like a temperature means that is T would be PV over nR is equal to T. Is it clear? So now put the values. What is P? P is 5.6. So 5.6 times volume is 12 over moles are 4 and gas constant is 0.0821. So try to solve it and get the answer.
Okay. Okay, I got 1.38.
Yeah, 1.38. That would be what?
That
Temperature.
would be the temperature, and that would be in kelvins, right?
In Kelvin, yes. And is there any need to check again? Should I check it or I think because I
No.
don't, no? All right,
No,
fine.
that one's okay.
Okay, all right. So the next question, yeah,
Okay. If I have an
if
unknown quantity of gas at a pressure of 1.2 atm, a volume of 31 liters, and a temperature of 87 degrees Celsius, how many moles of gas do I have?
hmm.
So, um, first we need to convert 87 degrees Celsius to kelvins.
Yeah. So what you need to do is the very first thing is I'm going to highlight which is something which is normal. Pressure is normal, volume is normal, and temperature is not normal. So I'm going to use another color. All right. So it makes the work really easy. Are you getting my point?
Yes.
All right. Good. So should we start this?
Yeah. So
Yeah.
87 degrees Celsius is 360 kelvins. So P is 1.2 times volume of 31 liters over
Mm-hmm.
X times um, 0.0821
Mm-hmm.
equals 360. So 1.2 times 31.
Yes.
Yeah, I'm just solving it.
Oh, it's sure, sure. Take your time, better. Take your time. By the way, I don't know why. Do the question. I'll bring the calculator. This looks really low, the temperature. Do the next question. I'll check it again.
Okay. I finished the second one. I'll recheck the first one as well.
Yeah, let me check it. This would be that would be 5.6 into 12 over 4 into 0.0821 is equal to, Soumya, I'm getting 204, 204.62.
I'll double check.
Because this temper 1.38 looks really low. Yeah?
Yeah, I'm double checking.
Okay, take your time.
Yeah, this time I got 204.6. So
Yeah.
I think when I put it in my calculator, I didn't use parentheses. And so it
Uh,
multiplied by 4 first.
All right, fine. So I'm going to rub this off because I was just wondering that the value is really low. Then I didn't have the calculator, so that's why I asked you that you checked it. You said yes, but it was nagging me. So now I have brought my calculator and I've done it. But I think this is the answer, right? 204.63. All right.
Yeah.
Now, what is the answer for the next question?
For the next one, I got um
Should
one
we do
minute, I had my calculator.
PV is equal to nRT?
I
So
got 1.26 moles.
yeah, this looks fine. Let me double check it, right?
Okay,
What is your answer? 1.2?
1.26.
All right, moles. By the way, Soumya, let me first check it, then I'll tell you one more thing.
Okay.
Yup. Correct, absolutely correct. By the way, Soumya, I was simply thinking that your teacher has written somewhere in the previous worksheet that he puts the unit alongside this. For example, when he's going to write pressure, he will write ATM with it. And then when he will write 12, he will write liter with it. So I think it's better to write the unit when you will do it in the paper. It's better to write the unit with it, right? It doesn't make any difference. You simply need to write down the unit. For example, with this, you will write ATM uh, dot L over mole dot K, and then you are going to cut ATM with ATM, mole with mole, and liter with liter, and then you will be left only with Kelvin, which you are going to put here. Does it make sense?
Yes, it does.
So it's better to write down the unit alongside because I'm not sure, but in some worksheet there was something mentioned about it. I think that need to write down the units. And here, yeah, here it is. Add numbers with units. So I think it's better to write the units. Yeah,
Okay,
here
got
it
it.
is. Here it is. In Boyle's Law, have a look. Your teacher has written ATM liter like this. Have you noticed? Yeah.
Mm-hmm.
Yeah. Can you see? So it's
Yeah.
better to write down the units because maybe your teacher will, if you will forget, maybe your teacher will cut marks. So it's better not to do that. All right.
Okay,
All
got
right.
it.
Now, good. Now we will do the next question the same way, right? So if I contain 3 moles of gas in a container with a volume of 60 liters and at a temperature of 400 Kelvin, what is the pressure inside the container? So I'm going to highlight 3 moles correct, 60 liters correct. Temperature is already given in Kelvin, so there is no need to change anything. Yeah. So what would be the formula, Soumya?
PV equals nRT.
And then we need to calculate what? Pressure. We need to
Yes.
calculate the
So,
pressure.
so
So
pressure equals nRT over volume.
very well done.
That would be 3 times
No,
0.0821
sweetheart, write 3 moles dot.
moles times
Mm,
what unit is the gas constant in?
Here it is. Here it is. ATM dash liter over mole dash Kelvin. Okay.
Okay.
So it would be
So
ATM.
0.0821 ATM liter over moles times Kelvin times 400 Kelvin divided by 60 liters
Hmm.
would give us the pressure. So,
Now look, Pite, mole would be cancelled by mole. Yeah. Um,
yeah,
are you getting it? Yeah.
yes.
So we are going to get pressure. So liter will be cancelled by liter. Kelvin will be cancelled by Kelvin. So we are going to left with ATM only. I hope it makes
So
sense.
it should be, yes, it does. So
Good.
it should be 1.64 ATM.
One. Perfect. 1.64 ATM pressure. Well done. And one thing more, Somya, by the way, when we were doing the worksheet yesterday, there were questions in which we were supposed to find out the pressure change. So it's better to subtract it. We have already subtracted it, right? So it's
Yeah,
better to get the answer with after subtraction, right?
yes.
Okay, now next one. If I have, yeah, read out the question on your own.
If I have 7.7 moles of gas at a pressure of 0.09 atm and at a temperature of 56 degrees Celsius, what is the volume of the container that the gas is in?
Yeah. The very first thing I'll request you to do it in the paper as well. That because you can, I think you cannot use the highlighter in the paper. Am I right?
Yes.
So what you can do is you will not highlight the things which are given with the correct unit, but do underline the unit which is given incorrectly, right? So you know the temperature here is given incorrectly. All right. So that's why I
Okay.
have used a different color because you cannot use a highlighter in the paper. So what you can do is leave the correct values as such and underline the value which is wrong. Okay. So
Got it.
now PV is equal to nRT and V is equal to nRT over V. Oh, P. Yep. So now put
Yeah.
down the values. Put down the values. So N is 7.7 mole. Dot R is 0.0821 ATM. Dot L over mole. Dot Kelvin times no, 56 plus, no, 56 plus 273, that is 329. You solve your own. All right, I am solving it here. Okay, I will not speak. I will quietly solve it and you solve it on your own. Okay?
Okay. All right.
When you get the answer, do tell me, right?
Okay. I'm almost finished. Okay, I got 2,310.9.
Liters. Don't forget to put the unit.
Right.
There you are. Well done. Shabash. Now the next question. Now do it on your own, right? I'm going to solve it here. I'll do it quietly and you do it on your own. I hope that you've got a paper and a pen, right?
Yes, I do.
Good.
Okay, I got 5.3 ATM.
Yeah, 5.34 ATM. Shabash. Perfect. And have you made this cancellation? Mole by
Yes.
mole, liter by liter, Kelvin by Kelvin. Any ambiguity while cancellation?
Nope. Understood.
All right, good. Now, next one. If I have yeah, read it.
If I have an unknown quantity of gas at a pressure of zero point 0.5 atm, a volume of 25 liters, and a temperature of 300 K, how many moles of gas do I have?
Okay.
Okay, so PV equals nRT. So PV over RT equals N. Okay, I got zero point 0.5 moles.
Well done. Yeah. I hope that you have checked the answer from here as well, right?
Yes.
Good. Yes. Next, please.
If I have 21 moles of gas held at a pressure of 78 atm and a temperature of 900 kelvins, what is the volume of the gas? Okay, so PV equals nRT. So V equals nRT over P. Okay, I got 19.9 um liters.
Yes, well done. 19.9. Okay, fine. I got 19.89. You have rounded it off, right?
Yes.
By the way, Soumya, I will suggest to write two decimal places. So I think I should better go with 19.89 letters.
Okay.
Okay. Next, please.
If I have 1.9 moles of gas held at a pressure of 5 atm and in a container with a volume of 50 liters, what is the temperature of the gas? So PV equals nRT, so T equals PV over nR. And I got 1602.67 kelvins.
Yes. Yes.
Yes.
Good.
Okay. If I have 2.4 moles of gas held at a temperature of 97 degrees Celsius and a container with a volume of 45 liters, what is the pressure of the gas? So if PV equals nRT, then P equals nRT over V. And I got 1.62 ATM.
1.62. Yes. 1.6218. Well done. Shabash. Are you doing it?
Yes. I got 142.70 moles.
142.70 moles. I think I'm getting a different answer. What is your answer? Tell me. Uh,
One hundred
say it again.
142.70 moles.
Okay, let me check again. I think I'm getting a different answer.
PV equals nRT. So I did PV over RT equals N. So 560 ATM times 25 liters divided by 0.0821 ATM times liters over moles times Kelvin times,
Okay, just let me check again.
okay.
Um, just a minute. So one, yes, fine, correct, absolutely correct. Yes, good. Next
Okay.
one. Yeah.
If I have 0.275 moles of gas at a temperature of 75 Kelvin and a pressure of 1.75 atmospheres, what is the volume of the gas? So PV equals nRT. So V equals nRT over P. So that would be I got 0.97 liters.
0.97 liters. Yes, correct. Yes, correct. Okay, good.
Okay. If I have 72 liters of gas held at a pressure of 3.4 atm and a temperature of 225 K, how many moles of gas do I have? So PV equals nRT, PV over RT equals N. Um, I got 13.25 moles.
13.25. Yes, correct. Now the last question, I think. No, it's done? Yes.
Yeah.
All right. Now the next one. Combined gas law. And the main thing is P1 V1 over T1 is equal to P2 V2 over T2. I've already explained you this. I think there is no need to explain it again. Am I right?
Yes.
All right, good. So if I initially have a gas at a pressure of 12 atmosphere and a volume of 23 liters and a temperature, let me highlight this, 12 atm, 23 liters and a temperature of 200 Kelvin, and then I raise the pressure to 14 atm, okay, and increase the temperature to 300 Kelvin. What is the new volume of the gas? Okay. So what I will do is P1 V1 over T1 is equal to P2 V2 over T2. Are you following me? Soumya, don't try it. I'll do it for you and then you will try the next one, okay?
Okay.
All right. So beta, what you need to do is you need to find so I'm going to write, let's suppose this is P1, this is V1, and this is T1. Are you getting it? This is
Yeah.
T1, and then this is P2, and then this is T2, and we need to calculate V2 is equal to question mark. All right. So what I will do, I'll tell you the simplest form of doing it, cross multiply it, right? Then write P1 V1 T2 is equal to P2 V2 T1. Are you getting it?
Yes.
And now we need to find V2. So I'm going to bring these two down. So it will become V2 is equal to P1 V1 T2 over P2 T1. Does it make sense?
Yes.
Yes. Now put the values. P1 is 12 times 23 times 2. No. 300 Kelvin over P2 is 14 times T1 is 200 Kelvin. Now put it in the, I didn't put the unit, sorry, I'll do it afterwards. So this would be 12 times 23 times 300 over, oh dear, 12 into 23 into 300 over 14 into 200. So the answer is 29. So volume would be 29.57 liters, which could be equal to 30 liters as well. But do write both the answers. Yeah. So have you understood it?
Yes.
Clear? Any question, beta?
Nope.
This is the trick. This is the trick. All right. By the way, I'm so sorry I didn't put the units. I can do it right now. This would be ATM. Yeah. This
Mm-hmm.
would be ATM. This would be liters, this would be Kelvin, and this would be ATM, and this would be 200 Kelvin. So Kelvin will be cut by Kelvin, uh, and then ATM will be cut by ATM, and we are left with only liters. I hope it clearly makes sense.
Yes, it does.
And don't forget this point. Don't forget this. I think this cross multiplication is clear.
Yes.
All right, good. So should I do next question or are you going to give it a try?
I'll give it a try.
Okay.
A gas takes up a volume of 17 liters and has a pressure of 2.3 atm and a temperature of 299 Kelvin. If I raise the temperature to 350 Kelvin and lower the pressure to 1.5 atm, what is the new volume of the gas? So P1 V1 over T1 equals P2 V2 over T2.
Mm.
So P1 is 2.3 atm and V1 is 17 liters and T1 is 299 Kelvin. So that equals 1.5 ATM times X over 350. And then I can cross multiply. I got 30.51 liters.
Okay. All right. I got 30.48 liters. It's fine. I
Okay.
got 30.48. You got 30.51. Yes, it's fine. Liters. Yeah. Okay. Good. Next question, please. Are you getting
Okay.
it?
Yes.
All right. Now I'm not solving it on the screen. I'm doing it on the paper. All right. So I hope that it's all fine if I'm not solving it. Or do you want me to solve it on the screen?
No worries. I understand it.
All right. Fine.
Okay. A gas that has a volume of 28 liters, a temperature of 45 degrees Celsius, and an unknown pressure has its volume increased to 34 liters and its temperature decreased to 35 degrees Celsius. If I measure the pressure after the change to be 2 atm, what was the original pressure of the gas? So we're solving for P1. So
Yes.
X times V1, which is 28 over T1, which is 45 Celsius to Kelvin. Okay, I got 2.5 ATM.
2.5. Yes, absolutely correct. Shabash. 2.518. So, oh dear. So pressure is equal to 2 point. Yes, same answer. All right. Yes. Okay.
Okay.
Now the next question.
A gas has a temperature of 14 degrees Celsius and a volume of 4.5 liters. If the temperature is raised to 29 degrees Celsius and the pressure is not changed, what is the new volume of the gas? So we're solving for V2. So P1 is, or it doesn't say what the pressure is.
Sorry.
If it doesn't say what the pressure is, then can I just make the equation V1 over T1 equals V2 over T2 since the pressures will cancel out because the pressure isn't changed?
Pressure is okay. Give it a try.
Okay,
Yes, if pressure is the same, then you can take the equation without the pressure, right?
right.
Good.
Okay, I got 4.74 liters.
Pardon?
I got 4.74 liters.
Yes, 4.74. Yes, absolutely correct. 4.74 liters. Well done. Next.
Okay, if I have 17 liters of gas at a temperature of 67 degrees Celsius and a pressure of 88.89 atm, what will be the pressure of the gas if I raise the temperature to be 94 degrees Celsius and decrease the volume to 12 liters? Okay, so finding the, we're solving for P2.
Hmm. And again, Somya, don't forget to write down the units alongside the number, right?
Right. Okay, I got 135.92 um
Yes.
ATM.
Yes, you are absolutely right. 135.92 ATM. By the way, Soumya, to be on the safer side, it's better to, after that, it's better to write like this. Oh no, 136. Yeah, 136. And if I will write in terms of significant figures, then what it would be? Let's suppose three significant figure.
Then it would be 135
Okay,
or it would be
fine.
136.
Yes. Okay, good. Okay. Now the next one.
Okay.
I hope you are doing right. P1, P2, V1, V2 on the
Yes.
numbers, right? Yes.
Okay, I got 97.5 liters.
97. I am getting a different answer. 97. I'm getting around 116 something.
Let me double check.
I'll check again. Yes, I have double checked it.
I'm just finishing up double checking. I
Okay.
think what I did wrong, I got 117 this time.
Yeah. Yes,
I
I
think what I
am.
did wrong is I typed in 40 as 40. I typed in 48 as 40.
Okay.
That's why.
So you are getting the same answer?
Yes, I got 117 liters this time.
Well done. Yes, well done. I was about to skip the rest of the questions and I was about to go to the next worksheet, but I think, Soumya, it's better to do all the questions, right?
Right.
What do you think? What do you suggest? Because you were getting the correct answers, so I thought that I should better skip the rest of the questions and we will move on to try to all the questions.
Okay,
What do you
that's okay.
suggest?
I think that's fine. We can move on.
Okay. Can we leave these questions then?
Yes.
All right. So Dalton's law of partial pressure. All right. Dalton's law of partial pressure. This says that uh, partial pressure is equal to the total pressure. I'm using the word partial pressure. It's not used in your worksheet, but I will use Dalton's law of partial pressure. Now, what is this Dalton's law of partial pressure? Let me explain you this. Dalton, it's the name of the scientist. He says that if the total pressure would be equal to the sum of the partial pressures. All right. So the total pressure is equal to the sum of the partial pressures. Now, let's suppose if we have a metal tank contains three gases, oxygen, helium, and nitrogen. If the partial pressure of the three gases in the tank are this, the 35 atm of O2, 5 atm of N2, and 25 atm of helium, what is the total pressure inside of the tank? So what you need to do, you need to add all the partial pressures to get the total pressure. So actually, total pressure, which is PT, is equal to sum of all the partial pressures. Okay, so this is the basic thing. Now you can apply it to get the answer. The first question is very simple, because you simply need to add 35 plus 5 plus 25. And you are going to get the answer, that is 65 ATM, right? But if we go to the next question, maybe we will have some other things, right? Are you getting it, Soumya?
Yes, I am.
All right, fine. So blast furnaces give off many unpleasant and unhealthy gases. If the total air pressure is 0.99 atm, the partial pressure of carbon dioxide is 0.05 atm, and the partial pressure of hydrogen sulfide is 0.02 atm. What is the partial pressure of the remaining air? Okay, so that means the total pressure is equal to the partial pressure of carbon dioxide plus partial pressure of hydrogen sulfide plus partial pressure of the unknown. Okay, so now total pressure is given to us, that is 0.99, and carbon dioxide is 0.05, hydrogen sulfide is 0.02, plus unknown would be X. So I'll add them up. It would give me 0.07 plus x is equal to 0.99, and x is equal to 0.99 minus 0.07, and x is equal to 0.92 ATM. Yes. So the final answer is 0.92 ATM. Does it make sense?
Yes,
So
it does.
partial pressure of remaining air. You will write partial, don't forget to write this. Partial pressure of the remaining air. Is it clear?
Yes.
Good. Now the next one. Do you want to give it a try?
Yes.
Okay.
So if the air from from problem 2 contains 22% oxygen, what is the partial pressure of oxygen near the blast furnace?
Well, it's quite tricky.
So the air contains 22% oxygen. Could you scroll up a little bit so I could see the equation one more time? Or up a little bit. Yeah. So partial, so PT equals sum of all of the particle pressure.
Yes, partial
PT
pressure,
for
some of all
question.
the.
So PT for question 2 was what did it say it was for question 2? It was 0.99,
Mhm.
and It's saying that if the air from problem two contains 22% oxygen, what is the
Yes.
partial pressure of oxygen near a blast furnace? So I'd need to find 22% of 0.99.
No, 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 no. If the air from problem two contains 22% oxygen, which is the partial pressure of oxygen near a blast furnace. All right. So first of all, I need to change 22% to 22 over 100. That would be equal to 0.22. All right. Now I need to find the partial pressure of oxygen. Okay. So PO2 is equal to percentage of oxygen into total pressure. What is the percentage of oxygen? 0.22?
Yeah.
0.22 into 0.99. So 0.22 into 0.9. This is 0.2178. So this would be the part. This is, yeah, this is a bit tricky. And this is different from the rest of the questions, right? So actually, you know what? They are telling you this is the answer you have found out for what? For the remaining year. All right. That means it was oxygen. All right. So you found the answer 0.92, but now they have converted it into 20%, that it is actually equal to 22% of oxygen. So what you need to do is you need to change it into decimal, right? So pressure, you know what? I'm going to tell you the rules. I thought that I should not better tell you before starting the worksheet because your teacher keeps the things simple and easy. But I have to tell this formula to you. This is the first formula which I told you. That is, total pressure is equal to sum of all the partial pressures, right? So now, what is partial pressure equals to? So one formula of partial pressure is actually percentage of the given thing multiplied by total pressure. This is one formula. There is another formula that partial pressure of a specific thing. Let's suppose I'll write oxygen here, of oxygen. So the percentage of oxygen multiplied by total pressure. This is not only not only the single formula which is going to be used. There is another formula which will be used. Partial pressure of oxygen could be equal to mole fraction of oxygen divided by total moles times TP, that is total pressure. So your teacher has not given these formulas, but I have written, because if they are using this formula, maybe in the upcoming questions, yeah, there are more questions. Maybe in the upcoming questions, we are going to come across these formulas. Are you getting my point?
Yes.
Yeah. So we need to, sorry for this scrolling. Yeah, here it is. So I'm highlighting it. One formula is this one, which is the simplest one. This is the second formula, and this is the third formula. Mole fraction would be given. Maybe in the upcoming question, they will give you moles of different things, right? So let's suppose they will give you moles of oxygen, moles of ammonia, moles of nitrogen. And then they will ask you for the partial pressure of nitrogen. So what you are going to do, you will put the moles of nitrogen here in the numerator, and you will put down the moles of all the other species, like, for example, moles of nitrogen, moles of oxygen, and moles of ammonia, times total pressure. So whatever would be the answer, that would be the partial pressure of nitrogen. Are you getting my point?
Yes.
Yeah. So maybe we will come across these questions in the upcoming questions. Sorry, these formulas in the upcoming questions. All right.
Okay.
Any confusion in it?
Nope.
No. So I'll write one. The simplest. This is the simplest. Second tough and the most tough. This is very important, Somia, that you get this formula, right? And you know what? Sometimes they will ask you, the most difficult question could be that, first of all, you have to calculate the partial pressure of each and every component. Then you, whatever answer you will get, you will add all the answers to get the total pressure. Okay?
Okay.
All right. So keep this thing in your mind. But when you will apply the question in this formula, total pressure would be given to you. Okay.
Okay.
All right. So, Soumya, we haven't done these three questions. So, is it possible that if you solve them and then post it on the WhatsApp group, and I'll check the answer and I'll tell you whether they are correct or not?
Okay. Sounds good.
All right. So, take it as your homework.
Okay.
All right. So, it's entirely
All
up
right.
to you if you want to post the solution today or tomorrow, but do it at your earliest. Okay.
Got it.
All right, Soumya, I have another class lined up, so I have to leave. So we will do the worksheets in the next class, right?
Okay. Sounds good. Thank you.
You're welcome. Thank you. Take care.
Bye-bye.
Bye-bye. Bye.